green blue. Okay, so the surface we can see it in black color, no color actually. Okay, this is another parameter why we talk about radiation is radiosity. The calculation of radiation heat transfer between surfaces involves the total radiation energy streaming away from a surface with no regard for its origin. The rate of which radiation energy leaves a unit area of a surface in all directions. For a black body, radiosity is equivalent to the emissive power EV, since a black body absorbs the entire radiation incident on it. Okay, next next variable is emissivity. The ratio of radiation emitted by the surface at a given temperature to the radiation emitted by a black body at the same temperature, which is denoted as epsilon. Varies between 0 and 1, of course lah. We have a ratio. Measure of how closely a real surface approximates a black body. If we have emissivity equal to 1, meaning that the surface is actually a black body, have a black body characteristic. Okay. Next, we have a combination of 3 of these, which is the first one is absorptivity, second one reflectivity, and lastly transmissivity. When radiation strikes a surface, part of it is being absorbed. Okay, part of it being reflected. Okay, absorbed, alpha reflected by rho, and lastly the remaining part, if any, is being transmitted. Okay, transmittivity, which is tau. So here in the figure here, okay, okay, we have incident radiation. Okay, here, so part of it will be absorbed. Okay, absorbed here. Part of it being reflected. Okay, and lastly being transmitted, meaning that some of the energy are being transferred to another medium or another metal. So what is the formula for each of these variable is actually absorptivity alpha is equal to absorbed radiation divided by incident radiation. Similar to the reflectivity, okay, reflected radiation divided by incident radiation. So transmissivity, okay, transmitted radiation divided by incident radiation. Okay, Kirchhoff law not only being applied, okay, in the electrical law, in heat energy also. I mean the Kirchhoff, try to mess up to give an idea lah, regard his idea in terms of heat transfer. Consider a small body of a surface area A as emissivity E and absorptivity alpha and temperature T contain a large isothermal enclosure at the same temperature. Recall that a large isothermal enclosure forms a black body cavity regardless of the radiative properties of the enclosure surface. The body in the enclosure is too small to interfere with the black body nature of the cavity. Therefore, the radiation incident of any part of surface of the small body is equal to the radiation emitted by a black body at a temperature T. So here we have what? G here. G is actually what? Incident radiation is equal to EV. So this EV again, emissive power times temperature, which is sigma, the Stephen-Boltzmann constant, temperature power of 4. The radiation absorbed by the small body per unit of its surface area is equal, okay, absolute, okay, absorptivity, okay, here, absorbed radiation, okay, equal to alpha G, where equal to alpha sigma T power 4. Radiation emitted by the small body is E emit equal to the epsilon. Okay, and lastly for okay, considering the small amount small body is in thermal equilibrium with the equation, the net rate of heat transfer to the body must be 0. So thus we can conclude that the absorptivity dengan with emissivity is equal. Okay, the view factor. Relation heat transfer between surfaces depend on the orientation of the surfaces relative to each other and as well as their radiation properties and temperature. View factor is defined to account for the effects of orientation on radiation heat transfer between two surfaces. Okay, view factor is purely geometric quantity and is independent of the surface properties and temperature. Diffuse view factor, so we have a two type. The first the two type of view factor. The first one is diffuse view factor, where the view factor is based on the assumption that the surface are diffuse emitters and diffuse reflectors. Second one is specular view factor. View factor based on the assumption that surfaces are specular reflectors. Okay. Here we consider radiation exchange between diffuse surfaces only, and thus the term view factor simply means diffuse view factor. View factor of a surface I to a surface J is denoted by F I to J or Fij, and is defined as Fij is the actually fraction of radiation leaving from surface I that strike surface J directly. Okay. So I think this one, okay, you can see, okay, what are different type of surfaces. Okay, we have a plane surface, convex surface, concave surface, and inner sphere. So it will denote a different, okay, fraction. Yeah. Okay. So actually, when we want to, to answer calculation problem regarding on radiation, so different from convection or conduction, where we have a table. So for radiation, we need to refer to this graph, so that we can get a different value of view factor. Okay, for view factor relation, we have a 4 fundamental relation. Okay, the first one, reciprocity relation. The second one, summation rules. The third one, superposition rule, and lastly, symmetry rules. Okay, for a reciprocity rule relation, is actually the view factor I to J, I to J is and Fj to I are related to each other. The relation is referred to as the reciprocity relation or reciprocity rules. For the summation rule, the conservation of energy principle requires that the entire radiation leaving any surfaces I of an enclosure being intersected by the surface of the enclosure. The summation rule is actually the sum of the view factor from surface I of an enclosure to all surface of the enclosure, including to itself, where must equal unity. Summation rule can be applied to each surface of an enclosure by varying I from 1 to n. Okay. The total number of view factors that needed to be evaluated directly for n surfaces equation become, okay, this is the general formula lah. Superposition rules, okay, which is the view factor from a surface I to a surface J, which is equal to the sum of the view vector from surface I to the part of a surface J. And lastly, for the symmetry rule, two or more surfaces that possess symmetry about a third surface will have identical view vector from that surface. If the surface J and K are symmetry about the surface I, then Fi to J is equal to Fi to K. Using the reciprocity rules, it can be shown that Fj to I is equal to Fk to I. Okay, this is combination of the view vector. Okay, don't worry about this. So for heat transfer, so again, you see that. Okay, so we need to know the thermal resistor network. Okay, what are the formula we want to find? The net rate of radiation, but the most important thing, okay, here you see that F here. So this is where the view factor being introduced into the formula. Okay, so different cases of radiation, we have a different type of formula. Okay, so this is the table. So finish. So that's all for our discussion on chapter 4 radiation. If you have any questions, just feel free to to ask to ask your question in the WhatsApp group. Okay, thank you.